Hello, and welcome to Electrolysis for Rust Removal, How I Did It by Benjamin Albert. Electrolysis rust removal is a method of removing rust from metal objects by passing a small electric charge through a electrolyte solution to stimulate an exchange of ions. The result is iron oxide, which is a black substance easily scrubbed off of the surface. The first thing you're going to need is some form of container to do the cleaning in. The container should be larger than the largest object you want to clean. In my case, I used a 12-gallon tote I picked up from the hardware store, and I made sure that this tote was made of a heavy-duty plastic so that it could withstand the pressure of holding 10 gallons of water. For this project and the size of the tote, I required 14 pieces of 12-inch long rebar that were placed inside the tote, and one that I used later for hanging off the pieces that need cleaning. Each piece of rebar was wrapped with a copper wire towards the top so that it could be fed through a hole in the wall of the tote without reducing the total height available of water. The rebar was placed such that it didn't touch the bottom of the tote, but came close. Zip ties were used through the tote to hold the rebar in place. All 14 pieces were placed around the tote as evenly distributed as possible. The final piece of rebar received a similar wire wrapping as to the pieces that were put in the tote. However, it was attached to a wooden board that straddled the center of the tote, providing a place to hang all of the objects that need cleaning. By using a piece of rebar, I can hang multiple wires with multiple objects, utilizing as much space as possible and getting more pieces done at once. Remember, this piece of rebar and the wire connecting to it should never touch any of the other metal that is involved in the process, other than the items that you want to clean. For the purpose of this tote, I was able to put about 9 to 10 gallons of water in. This was extremely useful because some of the pieces that come on candy knockers are rather large. The proportion of washing powder to water is 1 tablespoon per gallon, and this washing powder is used to create the electrolyte solution. You're going to want to mix it pretty well so that it will equally distribute, but if some of the powder ends up on the bottom of the tote, it won't cause any issues. Washing powder is not baking powder or baking soda. In fact, it's often called washing soda, and you can use a laundry detergent powder if you're not willing to go looking for the actual washing soda that everyone talks about. Each object that needs to be cleaned has to have the current running through it. So you take a wire, like the copper wire you used everywhere else, expose some of it, and wrap it around the metal of the object. You don't need a lot, it just needs to maintain contact. Then, at the other end of the wire, create a hook and wrap it around the piece of rebar that's straddling the center of the tote. This will create the second current flow to all your objects. Make sure none of your items are touching the rebar on the walls because the current must flow through the water and not directly from metal to metal. When doing the final connections, you want your objects to receive the negative charge, as shown by the red wire. and you want your rebar lining the outside of your tote to be connected with the positive charge. In order to make this work with modern day chargers, which often have a multitude of safety features, you're going to want to put a 12-volt battery in between your objects and the charger. The battery can be a car battery. However, I was able to use a smaller, less expensive one that can be often found in alarm systems. This shows the connection circuit for the entire system. Your battery charger will connect to your 12-volt battery, and your tote will also connect to your 12-volt battery. This seems stupid. In fact, you would think, why not connect the battery charger directly to the tote? Unfortunately, most chargers these days do not allow that to occur and will not provide current because they think there's a fault in the system. The truth is, there is a fault in the system because the charger was never meant to do this. To fake the charger out, you connect it to the 12-volt battery. And you must do this without having any of the tote connections attached so that the charger starts the charging process and acknowledges the valid circuit. From there, you start by connecting the negative line to the battery where it connects to the battery charger. I've tried doing it with the positive first, and it seems to trip the charger safety features. Maybe your charger will be different. Once the negative is connected, you then connect the positive, and you will see a reduction in the charging strength of the charger. That's okay. That means it's working. The other way you'll notice that it's working is bubbles, which is hydrogen gas, will start rising from the metal objects inside the tote. If you don't see bubbles, something isn't right. So, as I said, the bubbles will appear once you're connected and set up properly. If you don't see bubbles, you need to check everything. The time it takes to complete is going to vary based on what's on the object, and passing higher current or using more soap solution will not improve things. That can actually slow things down. You should check everything every couple of hours to make sure that you're not damaging the object. If you relieve the object in the electrolysis for days, if not weeks, you might actually start to see some of the metal from the object starting to release, which is not what you want. Also, you can do this with stainless steel that has gotten rust or steel in general, but toxic chemicals will be produced in the water, and you will need to use special dumping facilities for that water if you want to follow the rules and the laws and not poison your environment, which is important. Also, always wear gloves, whether you're doing stainless steel or not, but always wear gloves because you're putting your hands in rust water, and if you're doing antiques, you have no idea what's in there. With regular iron and brass, however, the rust water is just rust water. You can probably flush that right down a toilet. Okay, finally, some really important safety information. The gas, which is hydrogen, as I've mentioned multiple times, that is being produced during the electrolysis process is highly flammable and can explode. Don't operate anything that has an open flame of any kind or produces any kind of heat that might induce flame anywhere near this process while it's active. And always make sure that you have proper ventilation so that the gas will not build up in the space you're using. Remember, you're playing with electricity here, and electrocution is a possibility. Make sure you unplug everything before you start playing with the wires in the water and the objects you have in the water. I use a GFI-based outlet, which is a ground fault outlet, just as extra protection so that if something goes wrong, the outlet will flip its breaker. Hopefully that won't be necessary, but it's an added level of protection you should consider. As stated before, try and limit the amount of time between checking your objects. That way you don't do any damage. The idea is to get the dirt off, not to actually corrode the metal. Finally, try and get a charger that will let you use 2 amps. Anything more than that will just create extra heat, which you don't want, and waste energy, which is money out of your pocket. I hope this was helpful, and I hope you have success in your endeavors. As you will see in my other videos, the results are phenomenal, and the clean, polished, beautiful antiques become functional like they're brand new. This is the contents of the bucket prior to starting the electrolysis process. This is the electrolysis in action.